we're told that this function is 1 to 1, so that means that the inverse exists. So let's go about finding it. So the usual way is to replace, for convenience, f of x with y. So we'll write this as y equals x minus 3 over x minus 1. All right, now what we're going to do is interchange x and y. That'll look like this then. If I interchange those, I'm going to get x equals y minus 3 over y minus 1. And now I'm going to do the best I can here to solve for y. So this is a rational equation. We know what to do here. We're going to get the LCD and then multiply every term up there, all two of them, by that LCD, which is y minus 1. So as we've done before, take this y minus 1, the LCD, and write it alongside each individual original term. So it's going to look like this. We'll have x times y minus 1. Now I could have put the y minus 1 on the left side. It doesn't matter. Equals, now because I have more than one term here, I'm going to use parentheses. Y minus 1 times y minus 3 over y minus 1. And you can see what happens over here, right? The y minus 1's cancel. And that's going to work. That's going to be true if what happens? Y is not equal to 1. So let's see, where are we? I'm going to go ahead and multiply through here. So we'll get xy minus x equals, now when we canceled over here, those cancel, I get 1 times y minus 3 is y minus 3. Now, I'm trying to solve for y. Let's get these y's all on the same side. So you know what I think I'm going to do in 2 steps here? I'm going to subtract that y, and at the same time I'm going to add the x. So I'll get xy, now subtract the y, minus y, equals, and now add the x at the same time. So I'll get x minus 3. Now over here, at least I have the y's on the same side, but I've got 2 terms, and they both have y in them, so factor out y. So the plan is to factor out y. It'll look like this, y times. Now, if you remove the y, what's left? Well, you had an x and a y, you remove the y, so you've got an x left, minus. Now, what would you put here? Y times what will give you y? A 1, of course, and that's all equal to x minus 3. Now I'm just going to divide by that, and we'll have it. Y is equal to x minus 3 over x minus 1. But now I'm going to replace that y with its new name, which is f to the negative 1 of x, f inverse, and that is equal to x minus 3 over x minus 1. Okay, now that's going to make us stop and think for a minute. So look at our original function up here at the top left. What do we get? X minus 3, x over x minus 1, and what was the inverse? X minus 3 over x minus 1. What this says is that this function is its own inverse. So what we've got is f is this function here, and then f inverse is that same function here. Okay, now we need to look at this because this is saying that these functions is the same function. The function's its own inverse. Let's test this out. Right now, this is not going to be a proof. I'm just going to choose a number, or just pick any number. Just say x is equal to 6, right? I'm just picking some number. Now, if x is equal to 6, here's what I want to find out. If I put 6 first into f, get some number, and then put that into f inverse. Now, if these truly are inverses of each other, you start with 6, you process it with f, then you undo it with f inverse, you should be right back at 6. Let's see if it works. This is f inverse of, now what are you going to do with this 6? You're going to put that into f. So here's f up here, put a 6 here and a 6 here. We will get 6 minus 3 over 6 minus 1, f inverse of 3/5. And now what to do with the 3/5? Well, I'm going to put that into f inverse, which is right here. All right, so I'll replace those x's with 3/5. So it's going to be 3/5 minus 3 over 3/5 minus 1. Now, make these common denominators. So 3/5 minus I want that over 5, multiplied 3 by 5, so 15. And then 3/5 minus 5/5, that's a 1. And then that numerator is going to give us 3 minus 15 over 5, all over the denominator, 3 minus 5 over 5. For a minute there, I thought they were the same number. Now this is going to give us negative 12 over 5, divided by negative 2 over 5. That's a division of fractions, so negative 12 over 5 times, now invert and multiply, what do you get? 5 over negative 12. Oh, look at this. This is negative 60 over negative 60. Oh, no, wait a minute. You know what I did here? That's not a 12. What did I do? I was supposed to invert this. I wrote it as 5 over negative 12. And what is it really? It's really 5 over negative 2. Come on. All right, so now I get this. I get negative 60 over negative 10, which is 6. So it works. I start with 6. I process it with f, and then I process it again with its inverse, which is the same function as itself, and I'm right back at 6. So sure enough, this is a real interesting function. This function is its own inverse. It's its own undue function.